హలో, గుడ్ మార్నింగ్. గుడ్ మార్నింగ్ ఎంతమంది వచ్చారు? గ్రీన్ కెమిస్ట్రీ. ఎలక్టివ్. సో ఇది ఒకటే ఏంటి ఒక పేపర్ మొత్తం గ్రీన్ కెమిస్ట్రీ. చాలా తక్కువనే ఉంటాయి, 18 పేపర్స్ ఏమి ఉన్నాయి మనకు మొత్తం సిలబస్లోనే. మెటీరియల్ కూడా ఉంది ఆల్రెడీ. మెటీరియల్ కూడా ఉంది. చాలా తక్కువ ఉంటుంది సిలబస్, కాకపోతే కోరు ఎక్కువ ఉంటుంది, కానీ ఇది చాలా తక్కువ ఉంటుంది సిలబస్. 5 మెంబర్స్ వచ్చారు. మళ్ళీ ఒకసారి పోస్ట్ చేద్దాం గ్రూప్లో, ఎవరైనా వస్తారేమో. సరే. 7 మెంబర్స్ వచ్చారు ప్రజెంట్. So the green chemistry main objects are green solvents, green catalyst and efficient process, green and renewable raw materials, and environmental being products. So these are all some of the principles of green chemistry. Green chemistry అంటే ఏంటి మరి? So we are less wastage and less harmful to the environmental. So that is the green chemistry. So for example, we can prepare any chemical, so it is very less harmful to the environmental, so less wastage to the environmental. So this is the green chemistry about that. So we can synthesize the desired products, like we are getting 100% of the product, so we are getting no byproducts for this process. So that's why in nowadays there is a important role in green chemistry. So the green chemistry firstly started by Diels Alder, Ottoman Diels and Kudju Alder, the both scientists from Germany. So he was a well-known famous scientist, Ottoman Diels and Kudju Alder. They got Nobel Prize for this Diels Alder reaction for in 1950s. The Ottoman Diels and Kudju Alder. ఒక నిమిషం. Otto Hermann Diels, so he was a principal scientist. His student Kudju Alder. So both are prepared Diels Alder reaction in 1950. They got Nobel Prize for this reaction. So this is about the autobiography of Otto Hermann Diels. So he was from German. So his scientist is fellow student, the Kudju Alder, also collaborated to form a Diels Alder reaction. They got Nobel Prize in chemistry in 1950 for this reaction. So this reaction is very basic principle to the green chemistry. So this reaction totally depending on the green synthesis. That means it is 100% desired products. There is no byproducts, there is no wastage of the reactants. So that's why this is the very model reaction for the green chemistry. So this is a very fundamental initiation of the about the green chemistry. So what are the principles are involving in the green chemistry? So we have the 12 principles in green chemistry. These 12 principles are key role in the green chemistry synthesis. So the first one, prevent wastage. So for example, if you take the reactants, so we are getting 100% percentage of the product. For example, we have no byproducts. And at the same time, atom economy, every atom will be shall be uh, desired product. For example, there is no losses. For example, what is the Diels-Alder reaction? Yeah, we know very well Diels-Alder reaction. In Diels-Alder reaction, there is no byproducts are formed. So this is the Diels-Alder reaction. We are taken 1,3 butadiene plus ethene. So these both are under cyclization process involving in photochemical synthesis. Finally, we are getting the cyclohexanone. So here, so how many carbons are involving in reactant? How many hydrogens are involving in reactant? So finally, we are getting the product also same thing. So we have the same number of carbons, same number of hydrogens, final product. So that's why it is a atom economic reaction. There is no loss of hydrogens. There is no loss of carbons. For example, if in case of some other reactions, we can observe. So this is a simple reaction, condensation reaction. So here the methane condensation in presence of oxygen to produce water molecule plus carbon dioxide. So if you take here, the water molecule is the product, the carbon dioxide is a byproduct. As Orish, for example, if you take the carbon dioxide is a product and the water molecule is the byproduct. So, but we desired the product is carbon water molecule. So here 16 grams of methane. So the what is the mole ratio in this stoichiometric equation? The carbon is 1 mole and the oxygen molecule 2 moles, and the product in this product water molecule 2 moles and carbon dioxide 1 mole. So this is the mole ratio about the stoichiometric equation of methane condensation reaction. So in this reaction, every 1 mole of ethane condensation in presence of 2 moles of oxygen, it gives 2 moles of water molecule plus 1 mole of carbon dioxide. So this is the stoichiometric equation. Here, how much product we are getting? The total mass of reactant atoms. For example, here, the total mass, what is the total atomic masses of these both product, reactants? This is a methane 16, here oxygen 64, the total 80. But the total mass of the desired product, we take water molecule is we are preparing water molecule for choosing this reaction. If, for example, if you prepare carbon dioxide for choosing this reaction, in this case, the total mass of the desired product atoms is 36. So here, so how many atomic mass we are using reactants? 80, and actually we are getting only 36. So, but here only we have one water molecule 18 grams per mole molecular weight. So here we have two molecules. That's why 2 into 18, 36. So the what is the atom economic in this reaction? 36 by 80, 36 by 80 into 100. So finally we are getting 45 percentage of the atom economic in this reaction. So this is happening. It is not suitable for the green chemistry synthesis because we are wastage of so many reactants. So that's why it is not suitable for the this reaction. So for example, in case of Diels-Alder reaction, it is very useful. There is no byproducts, there is no loss of reactants. So that's why it is a very useful in green synthesis, green chemistry. So for, these 12 principles are mainly based on the green chemistry. These 12 principles are very useful to. For example, what is the 12 principles? We have the principles. ఒక్క నిమిషం ఆగండి, ఫోటో షేర్ చేస్తాను. prevent wastage, so there is no loss of byproducts, and at the same time atom economy, the reaction should be atom economy. So 100% of the atoms are involving, and you give the 100% of the molecules product. And less adjacencies, less adjacent, there is no harmful chemicals are releasing on these reactions. Also design beginning chemicals, so we take an initial stage of chemicals, not at intermediate stages. We are using at initial stages of the chemicals. We are getting the initial stage of chemicals from the natural resources like glucose or sucrose. These are all the you can make any biochemical compound. So we are taken from these natural resources compounds. Like if you prepare any protein, so we pick up the amino acids from the natural resources, not for the chemical resources. So that is the design beginning chemicals. And begins solvent and auxiliaries. Solvents, the solvent also less harmful to the um, environmental. For example, if you take some cases, we are using water. Water is a solvent. Water also one of the solvent, but the most of the organic reaction we are using solvents because of the because the most of the organic compounds are non-polar compounds. The water is a polar compounds. So that's why it is not suitable. If you take a organic compound and dissolve in water, it is a difficult process because the organic compounds all are non-polar compounds. It does not dissolve in water. So that is a fundamental thing. So that's why we are preparing some of the ionic solvents like ammonium, quaternary ammonium salts, and these are some of the ionic solvents we are preparing. After the reaction is completed, we are washing the ionic solvents with the water molecules, so that is less harmful to the environmental. So this is the fundamental thing. And design beginning solvents and auxiliaries. Design for energy efficiency. We are using less energy to reaction, conducting the reaction. For example, in the Diels-Alder reaction, we are conducting reaction on the photochemical synthesis. That means we are mixing the two reactants